All right. Section 1.2. Got a couple of ideas here. One of them is called the ruler postulate. And anytime you hear the word postulate, it means it's something we assume because it makes sense to us. It kind of, explains how the world works, but there's no way to actually prove it. You've got to start with some assumptions, and that this one, anytime it says postulate, it's an assumption. So the ruler postulate says that the distance between points you can find by subtracting. Basically, there are various ways of stating it, but it's basically the idea is if I've got something on a ruler, so let's say there's 0, 1, 2, 3, 4, and let's say my line segment goes from here to here. Let's pretend it's perfectly on there, right? Well, I can eyeball this and see, look, it's obviously 3, because I can kind of count 1, 2, 3, but you can also do this. You can take the two endpoints, subtract them, and take the absolute value. So if I went 1 minus 4, well, that's absolute value of -3, which is 3. Now, when it's simple like this, it makes sense to just count it. But if the numbers were, like that, we don't even want to use a calculator, right? And we get some other number, but that's the idea. Now, if the reason we have the absolute value bars is to make it always be positive. It doesn't make sense for distance to be anything but positive. They've got some sections where they'll give you a picture next to a ruler. The mistake I've seen people make the most often, when you're using a ruler, you want to make sure you round as they tell you to nearest. So something came up in another class. There was one where he kept getting the wrong answer, and it was because you were rounding to the nearest fourth. So when he put in 3/16, it was marking it wrong, even though this was a more accurate one. They asked to the nearest fourth, and so that's what made this wrong. Here's another basic issue here. We have segments and lengths of segments. They're symbolized differently. So if I have line segment AB, if I write AB without the line on it, it means the length of it, right? So I can say, like if I have a line segment like this, I can say that AB plus BC is equal to AC, right? This segment plus this segment is equal to the length of the whole thing, right? So that's a way we symbolize that. What else gets covered here? This brings us up to what's called the segment addition postulate. Again, it's a postulate. We can't prove it. Postulate. There we go. And it says that if A, B, and C are collinear, there should be 2 L's in there. If they're collinear, if they're in a line, then AB plus BC is going to equal AC. And it kind of makes sense to us. Imagine you were trying to tell whether or not 3 points were in a line. So you have A, B, and C, and maybe we don't know, is C here or maybe is C up here? Excuse me, is B here or maybe B is up here? Well, if B was up here, this distance would be longer than AC. Oops, you can't sit down. That up. What I was saying here is that AC would be, if B wasn't in the line, if B was up here, then AB plus BC would be longer. That AB plus BC would be longer than AC if it wasn't right in the line with them. So the segment addition postulate we also use to see whether or not things are collinear. All right, those are the big ideas. Let me stop.